Welcome to the Shika Serbu Motor channel. This channel provides easy-to-understand explanations of car mechanisms. The topic of this video is car air conditioning system and the reason why the range of battery EVs decreases in winter. First, please note, in this video, gasoline engine and diesel engine are referred to as ICE, internal combustion engine, while vehicle that run solely on batteries are called B-EV. If you own an ICE vehicle, you are aware that fuel efficiency decreases when you run the cooler on hot summer days. And, you also know that running the heater on cold winter days doesn't affect fuel efficiency. It's common sense. If you were to purchase a B-EV, based on experience with ICE vehicles, you can understand the decrease in range on hot summer days. However, you might raise an eyebrow in winter days. In this video, you will first learn about the structure and functions of the air conditioning system. And then you will learn about why the air conditioning system reduces the range of B-EVs. First, we will learn about heat pumps. A heat pump is a device that moves heat from one place to another. When a liquid evaporates, it absorbs heat from its surroundings. The evaporated gas is compressed to become a high-temperature and high-pressure gas. The high-temperature gas releases heat and returns to a liquid state. This process is called the refrigeration cycle, and it is utilized not only in car air conditioning systems but also in air conditioners for buildings, refrigerators, and the drying function of washing machines. The substance that undergoes repeated vaporization and liquefaction in the refrigeration cycle is called a refrigerant. In recent years, HFO, R1234YF, is used in automotive air conditioning systems. The cooling system consists of a compressor, a condenser, a receiver dryer, an expansion valve, and an evaporator. The compressor is rotated by the engine crankshaft via belt, compressing low-pressure gaseous refrigerant into high-temperature and high-pressure gas. Swashplate-type compressors excel in both performance and reliability, and they are used not only in passenger cars but also in large buses and buildings. Vane-type compressors allow for a small and lightweight design, and are primarily used in compact vehicles. Scroll-type compressors excel in quietness and efficiency, and are primarily used in compact cars. Generally, at an engine rotation speed of 1,000 revolutions per minute, the compressor suctions refrigerant at a pressure of approximately 1.5 to 2.5 kilograms per square centimeter, and discharges it at a pressure of around 14 to 16 kilograms per square centimeter. A magnetic clutch is installed in the pulley. When the air conditioner is off, the pulley rotates idly. When the driver turns on the AC switch, electricity is supplied to the magnetic clutch, and the pulley and the compressor shaft are connected. Then the compressor starts to compress the refrigerant. In recent years, some hybrid vehicles and B-EVs use an electric motor to drive the compressor. A condenser is placed in front of the radiator, where it cools the high-temperature and high-pressure refrigerant gas to condense it into a liquid state. A receiver dryer temporarily accumulates liquefied refrigerant and removes moisture and impurities from it. An expansion valve functions as a kind of atomizer, spraying the refrigerant in a mist form into the evaporator. The expansion valve is equipped with a refrigerant flow control valve that is responsive to the temperature of the evaporator. It adjusts the amount of refrigerant flow to prevent the temperature of the evaporator from dropping too low. The refrigerant is atomized by the expansion valve, but still remains in liquid form. As this liquid evaporates within the evaporator, it absorbs heat from the surroundings and transforms into a gas. The low-pressure gaseous refrigerant returns to the compressor and is compressed again. This diagram shows the state of the refrigerant and the heat exchange process. The high-pressure, high-temperature gaseous refrigerant compressed by the compressor is cooled in the condenser, transforming into a high-pressure liquid. In other words, the heat stored in the refrigerant is transferred to the atmosphere. Subsequently, the refrigerant is stored in the receiver dryer. The high-pressure liquid refrigerant is sprayed through the expansion valve, evaporating in the evaporator and absorbing the surrounding heat. In other words, it transfers the heat from the car cabin to the refrigerant. The low-pressure gaseous refrigerant returns to the compressor. As mentioned earlier, the refrigerant used in currently produced cars is HFO, R1234YF. Until the 1980s, CFC, R12 was used as a refrigerant, but it was discovered that the chlorine in CFC R12 was depleting the ozone layer. In 1987, the Montreal Protocol was adopted, leading to the decision to cease production and completely phase out CFC R12. HFC, R134A, adopted as a replacement for CFC R12, did not contain chlorine and therefore did not impact the ozone layer. However, due to its high global warming potential, approximately 1,430 times that of carbon dioxide, there has been a shift to HFO R1234YF, which has a warming effect about 6 times less than that of HFC R134A. HFO, R1234YF, which has a minimal impact on both global warming and the ozone layer, exhibits lower efficiency compared to traditional refrigerants. It is commonly said that about 5 to 10 horsepower of engine load is increased to drive the compressor. This is reason why fuel consumption increases when the air conditioner is turned on. The heating function warms the air inside the vehicle cabin through a heater core. The heater core is a small radiator, connected in parallel with the radiator and the engine cooling circuit. Engine coolant circulates through it, dissipating its heat into the car cabin. In ICE vehicles, the engine coolant can be utilized as a heat source during heating. In other words, there is a readily available heat source without any additional cost. When warm and humid air is cooled by the evaporator, moisture in the air condenses and drips down, being discharged outside the car through the drain hose. On high temperature and humid days, the puddles in the parking lot are caused by the discharge of moisture. Please note, if the drain hose is clogged or detached, a puddle may appear on the floor of your car, instead of the parking lot. To dehumidify, the compressor needs to operate, which increases fuel consumption. The temperature and air vent selection control is managed by altering the airflow through air mix doors. Currently, the air conditioning is set to fresh air intake, the blower switch is on, the AC switch is off, full cooling, and the face vent is selected. Pressing the recirculation switch changes the air intake port. When the AC switch is turned on, the magnetic clutch of the compressor engages, and refrigerant flows through the evaporator. By pressing the temperature set button, the airflow through the heater core changes, adjusting the temperature of the air being blown out. Generally, air outlets are switched between face vent and foot vent, windshield defrost, and windshield and foot vent, using air mixing doors. There are 2 reasons why the range of B-EV decreases. One of them is due to decreased battery performance and low temperatures. The other is due to the B-EVs do not have a heat source for heating. In ICE vehicles, the system operates as a heat pump to dissipate the heat from the car cabin to the outside during cooling. During heating, the engine coolant serves as the heat source. The air conditioning system of B-EVs operates as a heat pump, similar to ICE vehicles during cooling. During heating, due to B-EVs do not have heat source like ICE vehicles, the heat pump operates in reverse. It transfers heat from the outside of the vehicle to the car cabin. The air conditioning system of a B-EV is equipped with an in-car evaporator and an in-car condenser within the vehicle cabin. A circuit with an expansion valve is added to the outer heat exchanger, allowing it to function as both a condenser and an evaporator by switching the refrigerant flow path. When using the cooling function, the outer heat exchanger works as a condenser for heat dissipation. the in-car condenser is bypassed, and heat absorption is carried out by the in-car evaporator. When using the heating function, refrigerant flows through the expansion valve, and the outer heat exchanger works as an evaporator for heat absorption. The in-car evaporator is bypassed, and heat dissipation is carried out by the in-car condenser. In this way, in B-EVs, since it is necessary to drive the compressor even during heating, electricity is consumed, resulting in reduced range. Furthermore, there is a significant drawback to heat pump heating. When the outside temperature drops below -10 degrees Celsius, its efficiency drops significantly, and the heating capacity becomes insufficient. For this reason, B-EVs are equipped with a PTC heater. PTC heaters are a type of electric heater that can generate heat regardless of outside temperature, but their high power consumption further reduces range. Development to improve the performance of heat pumps is also progressing. During extremely cold conditions, the refrigerant evaporation quantity in the outer heat exchanger decreases. The gas injection system separates the refrigerant into gas and liquid, using a separator before entering the outer heat exchanger, and injects the gas into the compressor. As a result, the refrigerant quantity in the outer heat exchanger increases, leading to improved heating performance during extremely cold conditions. This system was first adopted in Toyota Prius PHEV, allowing it to maintain heating performance without the engine operation even at -10 degrees Celsius. The waste heat recovery system utilizes a water-cooled outer heat exchanger. It circulates the coolant that cools the EV motor and the inverter into the outer heat exchanger, thereby increasing the refrigerant evaporation quantity. This system was first adopted in Hyundai's EV, allowing it to maintain heating performance even at -20 degrees Celsius. Thank you for watching. If you enjoyed this video, please consider subscribing to our channel. We'll see you in the next video.